This is Mr. Ashton going through the Mathematics Numeracy Unit 1 Non-Calculator Intermediate Tier paper from the autumn of 2018. So, first page is the formula list, and then on to this question here. Okay, the question says, Fionn is making a box for a present. The box is a cuboid. Fionn draws a sketch of the net of the cuboid. Let me just focus the camera a bit better so we get a nice clear picture. And it says write down the height, length, and the width of the box. Now, all that information is up here. I can see that either the length, the width, or the height of the box, it doesn't matter because it's a cuboid. I'm going to say that the height is the bit that comes and stands up here. So that would be 4 centimetres is the height. The length, I'm going to say, is this long distance going across, so that's 6, and the width is how far the box goes back, so the width would be 5 centimetres. However, as long as you've got 4, 6 and 5 in any order there, you will pick up the marks, okay? Now, part B, it says, let me just move the camera a bit here. It says, after Fionn has finished making the box, she cuts and sticks coloured string around each edge of the box. Okay, now what I'm going to do is just draw what that box would look like quickly. So we know that once it's made, it looks something like this. Okay, now when we're talking about edges, these are the lines that make it would be the same as this edge here. And let's make the box see-through. I'll do dotted lines, the ones where it's going see-through. And the one at the back here. Okay, so all of those would be edges. And similarly, I've also got all these long edges here too. So 2 there, the length, there, and there. And I've also got these ones going back. Has always got, at least, every cuboid has got 12 edges, okay? It says, the string costs 3p for every 2 centimetres. How much will Fionn spend on the string? You must show you're working. Well, the orange one is my height. So I know I'm going to have 4 lots of 4 centimetres because there are 4 edges that are the height. So that's a total of 16 centimetres. I've also got 4 lengths, so it's going to be 4 times 6 centimetres. So that's going to be 24 centimetres. And then I've also got 4 lots of the width going back as well. So that's going to be 4 times 5 centimetres, so that's 20 centimetres. Okay, add all those together and you will get 60 centimetres in total. We're told here that string costs 3p for every 2 centimetres. And if it costs 3p for every 2 centimetres, I'm going to say 3p equals 2 centimetres. Then to work out 60 centimetres, I want to times by 30. Whatever I do to one side, I do to the other. 3 times 30 is 90p. Okay, so the cost of string, 90p. Over the page, the next question says, Rob has carried out a survey. He asked 25 students how many times they visited the library last month. His results are shown below. So we've got a tally table showing here that no one went 0 times, no one went 5 times, and we had 6 people who went once, and so on. We're then asked to, using Rob's results, following the answering questions, what is the range of his results? Well, the highest value is 4, take away the lowest value. 4 take away 1 is equal to 3, so the answer is 3. We're then asked what is the median. So we've got 25 students here. So we're looking for the middle of 25 students. And the way to work that out quickly is to add 1 to your total and divide that by 2. So 25 add 1 is 26. 26 divided by 2 is 13. We're looking for the 13th person, or the 13th number of times. So we've got 1, 2, 3, 4, 5, 6 taken up so far. Then another 5, so that's 11. 12, 13. So the 13th student was this person here. Okay, it was literally the last person on number 2. So that would be my visit there. Okay, so we're given a weighing scales here, and on the weighing scales we've got a stack of books, a weight here, and then two of the same books there. It says, what is the mass of one book? Well, first of all, Let's cross off, let's take off a book off each side, and then let's take off a book off each side to keep it balanced. So we can say now that 1, 2, 3, 4, 5 of the books, so 5 books, is equal to 1,750 grams. If I want to find the weight of one book, what do I have to do to 5 to make it 1? Divide it by itself. 5 divided by 5 will give me 1. And then divide that by 5. Now that's a slightly trickier task to do here, so what I'm going to do by the side is bus stop division. So 51750. How many 5s go into 1? Can't count in 5s and get to 1, so we take that across the remainder. Count in 5s till you get to 17, because in 3 times remainder 2. 5 times 3 is 15. 15 to 17 is a remainder of 2. 5 into 25 goes 5 times. 5 into nothing does not go, so my answer is 350 grams. We're then asked, we're then told, Rob balances some identical dictionaries. 10 dictionaries are on one side, 2 dictionaries and 3,200 grams of weight is on the other side. Let the mass of one dictionary be X grams. Use the information to write an equation above. Now that's quite a straightforward one as these go. They're usually much wordier than that, much trickier. 10 dictionaries, and the dictionary is X. So 10 dictionaries, 10X, is equal to, because they're balanced, 2 dictionaries, so 2X, and, so plus, 3,200 grams. Okay, now in terms of what we've done there, we've actually answered everything there. We're then asked to find the total mass of all 12 dictionaries. Then if we write here 10x is equal to 2x plus 3,200 grams. Could drop the G if we wanted to here and put it in the final answer. I'll leave it there for now. I'm going to take 2x off each side, so I'm getting rid of the smallest x, so that we've got x's on one side. 10x take away 2x would be 8x is equal to 3,200 grams. I'm dividing both sides now by 8 because that's the coefficient, it's the number in front of the x. Gives me x is equal to 400 grams. Now, as we normally get with a numeracy paper, it hasn't asked me what is, it's asked me something else. It says, what's the weight of all 12 dictionaries? Well, x is one dictionary, so we know one dictionary is 400 grams. So 12 dictionaries would be 12 times as many, so 4800 grams. So I'd write that in there. Okay, so just watch out for that. They like to do that in a numeracy paper. Okay then, over the page it says that we will be assessed on the quality of the organisation, the communication, actually in our writing. That's only worth 2 of those marks there. The maths is still 4, okay? So be mindful of that, okay? It says, Treff Tiles sells boxes of small wide tiles. 3 different boxes are available. Box of 25 tiles for £7.50, box of 40 tiles for £11.20, and box of 100 tiles for £29. So what we need to do then, it says Katrin is buying a very large quantity of these small tiles to cover the walls of her bathroom. Which box offers the best value for money? Now, the problem at the moment is that they're all different amounts of tiles for different amounts of money. So what we need to do is find a value that they all go into, and then we can look at it on a price-by-price comparison, okay? Now, because I am being assessed on here, I'll just make that clear to someone marking my work and say, to make a fair comparison must look at price for same number, I can't write, number of tiles. Okay, so my top tip is always to come to the 2 biggest numbers. Find a number that both 400 and 100 go into. Now, if I count in 40s, so 40, 80, 120, it doesn't go into 100. But I know that 40 will go into 400. I know that 100 will go into 400 as well, okay? So what I'm going to do here is say 25 tiles. If, by the way, if we can find them that those 2 will fit into, I guarantee that one will fit in as well, okay? So 25 tiles will equal £7.50. So I'm now going to make that to 400 to then compare them all. So if I double it, I'm going to find that 50 tiles would equal, now part of an OCW question, make sure you write in the tiles and pound signs, okay? Double of £7.50 is 15 quid. And then 100 tiles would be 30 quid. So I already know that's not better value than that because that's £1 cheaper for the same amount. And then 400 tiles would be 4 times as much. So 4 times by £30 would be £120. Okay. Then if I use the 40 tiles, is equal to £11.20. If I wanted to find 400 tiles, I find that is £112. And then for the 100 tiles at £29, I might take this in 2 steps. If I double it, I'll get 200 tiles to be £58. And then double of £58 is 116. Okay, so I've already stated why I'm getting them all the same number. I'm then going to put a box around each of these ones here. And then I need to choose which offer is best. This one's the cheapest. So if I highlight that, that's the cheapest one there. State it, arrow pointing to it, cheapest option. And then I'll say that the cheapest option to buy is 40 tiles for £11.20. Okay. Okay, then over the page, it says Treff Tiles sell a wall measuring 10. Sell a wall tile measuring 10 centimeters by 20 centimeters. How many of these tiles would need to cover a wall measuring 3 meters by 4 meters? Now, that's where they've tried to catch us out. 10 centimeters, 20 centimeters, 3 meters by 4 meters. They have to be in the same unit of measure. Now, if I draw out this wall, it's very generically here, we know now because that's in centimeters, I'm inclined to keep that turn that into centimeters. So that would be 300 centimeters by 400 centimeters. In terms of what we've got here, then we'd have 300 centimeters there, 400 centimeters there, and we know that we've got a tile that takes up 10 by 20. So what we could do is split to see how many 10s fit into the 300s, how many 20s fit into the 400. That would do it. So if I show you that way, we would do 300 divided by 10, which would give me 30, not 30 centimeters, sorry, which would give me 30 tiles going down. And then 400 divided by 20 would give me 20. So we would run 20 tiles widthway, so we'd have 30 by 20 tiles. So 30 times by 20 would give me 600 tiles. Okay, another way to do it is probably the way that I usually prefer to do it in all honesty, is say 3 times by 4 is 12. 1, 2, 3, 4. 1, 2, 3, 4 centimeters squared. That is the area that I'm going to tile. One of these tiles is worth 10 by 20, so 200 centimeters squared. And by doing 120,000 centimeters squared times by 200 centimeters squared would also give me 600. If I divide top and bottom by 100, I get 1,200 divided by 2, which is also 600 tiles. Okay, so both ways will give me 600. And then part C, it says Treff Tiles has 5 boxes of tiles on special offer. All the tiles are in each box are identical. It says 3 of these boxes contain tiles that will tessellate. Manon is asked to select 3 boxes. Which 3 boxes should she choose? Now, to tessellate, all the things must meet together. All the tiles must meet together, leaving no gaps. So if you think of tiles that you might see them just literally doing that. So rectangles. And the reason why they all meet together is because these angles here are all right angles. 4 right angles make 360. All of the angles must meet together to make 360. So if rectangles do it, then squares definitely will as well. Rhombuses are like pushed over rectangles. So if I draw that there, if I draw another one there, you can see they meet together, and the same would be true up there, so that's going to get it. A regular pentagon, now. A regular pentagon looks something like that. It's a five-sided shape where all the sides are the same. And then if you work out the angles inside the pentagon, they go up to 540. I'm not going to teach us how during this bit because it's such a low marker one. But if you're unsure, put a star next to that question, go and do some research on it. Divide it by 5, we'll find that each angle is 108. Now, I know that 108 is not going to go into 360, so that is not going to go into it. A right angle triangle here, well, again, we've got the 90, so if I put one upside down there, there, and there, and then I could just have the other triangles doing that, okay? So yes, that's going to do it. Circle, well, that certainly will not fit together snugly. There's no way of getting circles to do that, okay? So that wouldn't anyway, okay? So the box I want A, B, and D. Over the page, number 4, it says the mass of rubbish recycled is given as a percentage of the total mass of rubbish. The percentage of rubbish recycled by people living in 8 small towns was recorded below. The results for the first week in July 2005 are shown in the scatter diagram. So we've got in 2000 they recycled 50%, and then for some reason it went way down. Oh, right, okay, so these are different towns. So that's town A. There's a very low number of people in here. Half of their rubbish is recycled. More people in this town, way less. More people in this town, less again. More people in this one, less again. But then, as these numbers go up, so do the amount they recycle. So they're all scattered everywhere. This has got no correlation. It then says, underneath, it says complete each of the sentences below. In July 2005, 2 of the 8 towns had the same number of rubbish. So we're looking for the 2 numbers here. So these 2 guys here had the same amount. The percentages, 2 of the 8 towns had the same number of people. I'm misreading it, sorry. Had the same number of people. So we're looking along this axis here, here, and here. So we need to go and read off what those percentages were. So one of them's 40. I can see that nice and clearly. And the other one is in between 0 and 20, so that must be 10. It then says the town with the least number of people had set a target of 45% of rubbish to be recycled. The town beat this target by, so the least number of people, so we're looking along here for the least number of people, that's this one here, they are in between, they're in between 40 and 60, so that's 50. They're supposed to get 45, they beat it, they got to 50, so that's beaten by 5%. The next page says, explains why it is not reasonable to use this data to estimate the percentage of rubbish recycled in a town of 9,000 people. Well, it comes back to the pattern of the data. You can't draw a line of best fit. They're all scattered around everywhere, okay? So I'm going to say that there is no correlation. No correlation to predict a town of 9,000. If all the scatters had literally just been going up in a straight line or coming down in a straight line like that, it would have been a perfect way to do it. But because they're all scattered everywhere, we couldn't do that. We're then told here that in 2016, Merriford Town Council recorded a total mass of rubbish recycled. Of this mass, 130,230 tonnes was paper and cardboard. The total amount of paper and cardboard was 1/4 of the mass of the rubbish selected. Okay, so 1/4 is this much that we've just been told is paper and cardboard, and that's paper and cardboard. Okay, we're then asked to work out what the total amount is. Well, if we know that 1/4 of the rubbish was 130,230 tonnes, then that's 1/4 of them. To work out a whole, I just need to times it by 4, but I'll do that in 2 bits. I'll double it to find 1/2 of the rubbish recycled to be 260, and then 460 tonnes. So that bit was easy enough. And then I'm going to, if I know 1/2 of the recycled amount, then to find the whole, I need to double the 260,000 and double the 460, which I'll do separately. So 1 whole will be equal to 520,000 tonnes. And then, is that going to go? No, it's 920. Okay, then over the page, we're told a badge is made by using metal button and sticky tape. Lulu's craft shop, and then it tells us the cost of these things here. And it says, Elwyn decides to buy metal buttons and pins to make badges so that there are no metal buttons or pins left over. So if we bought 24 pins and 42 metal badges, there's obviously going to be some metal badges left over. So I buy exactly the same amount of pins and metal buttons. It says he wants to buy the least possible number of packs of metal buttons and bags of pins. Show Elwyn should buy 4 packs of metal buttons and 7 bags of pins. Okay, so they've already told us the answer here, so all we have to do is go and show that 4 packs would work, 7 bags would work. So if I say here, buttons, and then I want to count this 4 times, they told me that it should be 4 packs. So we get 42 in a pack, 2 packs we get 84, in 3 packs we get 126, and in 4 packs we get 168. Whereas of the pins, I want to count in 7s now, and hopefully the first number to join up will be 168. So it'll be 24, doubled will be 48, 72, 96, 120, 144, 168. Yes, 7 or 4. Okay, so I'll just say here. So I'll just say here, the same number is 168 of buttons and pins, which is actually what we call the lowest common multiple of those two there. It then says, what is the maximum number of badges Elwyn can possibly make using 4 packs of metal buttons and 7 bags? Well, we just answered it. It's 168. Okay, that seems like a bit of a strange one, but I have checked the mark scheme. That is the correct answer. Okay. Over the page, it then says each pin is stuck onto a metal badge using approximately 2.5 centimeters of sticky tape. Elwyn plans to sell the badges to make the maximum profit possible. How many rolls of sticky tape should he buy? Well, we know that he makes 168 badges. We know that 1 badge is equal to 2.5 centimeters. I want to make it 168. Okay, so to do that, then we are going to do. I'm going to double it there to make 5 centimeters is 2 badges. And I'm told if I go back here, we're told that 60 centimeters is a roll of the tape at 52 pence. So then I want to work out how many badges can be done in 60 centimeters, which is 1 roll of tape. So 5 times by 12 would give me 60 centimeters. Whatever I do to one side, do to the other. So 24 badges would be 60 centimeters, which is 1 roll. Now I want to get that up to 168 badges. So if I say 24 badges is equal to 1 roll, then if I double it to get 40, in fact, actually, I'm not going to do that because I know 24 there. I times that by 1, 2, 3, 4, 5, 6, 7. I know that 168 badges would equal 7 rolls. So I've times both those by 7. So the number of rolls of tape that I need is 7. We're then told Elwyn sells all the badges for 50 pence. Calculate the maximum profit he could make. Okay. Well, let's start off then. We know that he needs 7 rolls of tape. So if we do 7 times by, was it 52 pence for a roll? Yeah, 52p. Don't know how to do that off the top of my head, so I'm going to split the 52 pence up into 50 and 2. and times it like that. 7 times 5, 35, add the 0, 350p and 14p comes to £3.64. Highlight that, we'll come back to that. We're told that he bought 7 bags of pins. So a bag of pins is £1.10. So we need to do 7 times by £1.10. That's quite nice, actually. That's £7.70. So there's another value that we need to add. And we're told that he needed 4 bags of the metal buttons. So we know that 1 bag is equal to 250. So 4 bags would be 4 times 250, which again is actually quite nice. That's 10 quid. Right, so that's his total cost. Let's just double check everything above. It says each pin has a metal button and the sticky tape. Okay, so that's absolutely everything. So the total cost would be 10 plus £7.70. So I'm just going to get this all in column order, which you can see what I'm doing. And then 364, 4, 13, carry 1, 10, 11, 21, 34. That's the total cost. And then we're going to sell each one for 50p, and we know that we're making 168. So the best way to think about this, rather than saying it's 168 times by 50 pence, how much of a pound is 50 pence? It's half a pound, isn't it? So that means that this must be half of the value here. So the total that we're going to make from selling is going to be £84 from sales. This is my cost. So then to work out the profit, which is what I've been asked for, what is the maximum profit if every batch was sold? I want to do 84, take away the 21.34. I'm sure there's going to be some room on the other side. Is there not? Ugh, they haven't given me much room here, so I'll just have to fill this in up in this corner here. Sorry about the mess. So 84 take away 21.34. Fill in zeros there. We'll have to steal all the way from here. 10 take away 4 is 6. 9 take away 3 is 6. 3 take away 1 is 2. 8 take away 2 is 6. So the maximum profit is £62.66 profit. Okay. Okay, then question 6. So I think this is the first question on the higher paper. It says mould is on a bearing of 0.65 from roofing. What is the bearing of roofing from mould? Okay, now the best way to do this for me is to always write it. So if we're from roofing, that's where we're measuring. So I'll do here is north, and this is roofing. 65 degrees will be above 90, so it's going to be here roughly. So that's going to be mould. Now I know this is 65 degrees. I've dropped the third figure, the 0, and I know that these two angles here in parallel lines must add up to 180. So I want to do 180, take away 65. So that's going to be 115 degrees. So hopefully that's one of my options. No, it's not. I'm lying. It's not 115 degrees. This is 115 degrees. So then to go and work out what this angle is here, I need to take away from 360. Now that's really good news. That answer wasn't there. They usually put in the wrong answer, but it's not very fair. If you've worked out that's 115 degrees, just circle that one. So then if we do 360, take away 115 degrees, we're going to get the answer of 245 degrees. The next one says Rill is on a bearing of 330 from Ruthin. So again, we're from Ruthin, so north R. 330 is nearly a full spin in all honesty, so it's up here somewhere. So that's 330, so this bit here is 30, the whole way around it there is 330. It then says, what is the bearing of Ruthin from Rill? So what's this angle here? Now again, these two angles have to make up 150. Now this one is have to make up 180, so this must be 150. So 150 is your answer there. Part C, it says when it is 1940 in Cardiff, it's 23:40 in Dubai. What time is it in Dubai when it's 13:30 in Cardiff? Now, the way I'm going to draw that is say C here for Cardiff. Dubai is on exactly the same time. I know this is 1940 here, and I know at exactly the same time the actual time in Dubai is 11:40. So to get from Cardiff to Dubai time, I'm adding 4 hours, and to get backwards, I'd be taking away 4 hours. Okay then, so when it is 1:30 in Cardiff, I'm going to add 4 hours, so it would be, what's that, 17:40? 17:30? Yeah, 17:30. We're then asked, when it is 2:10 in the morning in Dubai, what time is it in Cardiff? We're going to take away 4 hours off that. Now, the best way to take away 4 hours off that is if we do that time there, come back 2 hours. What's 2 in the morning? Take away 2 hours. It would be 12 at night. And then take another 2 hours off that. 22:10. So we're looking for 22:10 there. Okay. Okay then, question 7. Have a quick pause of the video. Okay then, so with parallel lines then, this is quite a tricky one because it's got loads of stuff going on. So here, and these two here. And we're asked to go and find A, B, C, and D. Well, let's go alphabetically and try and work them out, okay? So these two lines here are parallel. I'm going to turn them literally around so that they're used to where I see them here. Now, I can see here that I've got this angle here, and they've asked me to go and work out what this angle here is, angle A. Okay? Now, I can see that I've made a backwards C there, but what I'm going to try and show using tracing paper is that if this angle here is 125, then I can slide it along this transversal here to tell me this angle must also be 125, which is not angle A, it's the one on the other side of angle A. But I do know that these angles here on a straight line add up to 180, but also if you can identify C angles, then you should know those two add to 180 anyway. So 180 take away the 125 would give me 55 degrees. So angle A is 55 degrees. Okay. The next one I'm looking for, where's B here? Now, B is along this parallel line and this parallel line here. So again, I'm going to have them coming towards me like I'm used to, which is nice and flat anyway, which they sort of are already. So going back to the tracing paper there, the angle that we know is 76. Now that's this angle made by these two lines here, and B is here. Now, can you see that I can just literally just shift that across the transversal there, hit on each other exactly. It's just being able to identify where those are. And again, if I highlighted angle B, the one I'm looking for, anything along this set of parallel lines that I'm looking for, so this line here, I make an F. Those two angles there are always the same if you make an F shape. Now, if I know angle B, I definitely know what angle C is because it's angles on a straight line again. So 180 take away 76 would give me 104. And then finally, go and work out what angle D is. Now, this is within parallel lines twice. So if I can go and move my C angle, which is 104 here, up, it would be the same angle there and the same angle there. So that's 104. That's on a parallel line still again. And then these two are both parallel. So if you look, I can actually just move that angle there, and that's also what D is. Okay, so there's no sort of ways that you can draw letters there. It's being able to understand that those angles can move around and shift around the transversal lines. Okay, so that is 104 also. Okay, then question 8. And be careful with this. It's hidden away in this question what to do. It says, Mrs. Butler asked all her friends how many pairs of shoes they own. Here are the results. Number of pairs of shoes, 1 to 6. One person has 1 to 6 pairs of shoes. Number of pairs of shoes, 7 to 12. 5 of her friends had 7 to 12 pairs of shoes. And then number of pairs of shoes, 13 to 18. 8 of her friends had between 13 and 18 pairs of shoes. Which is the modal group? Now, we can work that out quite easily. The modal group is the most popular group, which is 13 to 18. It then says, Mrs. Butler says, most people in Wales own more than 12 pairs of shoes. And that's absolutely true based on here because the modal group is 13 to 18. However, the key thing is, most people in Wales are not necessarily your friends, okay? That's not true, okay? So we'll say no here. We'll say 14 people have been asked. That's how many people have been asked in total. 1 add 5 add 8 is 14. 14 people who are all friends is not the population of Wales. It's not enough. You need to ask way more people than that, okay? Around about 200-300 people. It's not the population of Wales. It then says, write down different groups Mrs. Butler could have chosen so this data can be analysed more accurately. Well, as you can see, between 1 and 6 is quite wide-ranging, 7 and 12, 13 to 18. So just anything to analyse it more accurately, it just needs to have more groups and less space between the groups. So I'm literally going to say number of pairs of shoes would be between 1 to 3. And then make sure you don't have any that cross over here. If I've got 1 to 3, what if I own 4? 4 there, 3.5 doesn't exist. I can't own pairs of shoes. So 4 to, now there, I could be a size 1, 2, or 3 there, so I've got to have the same here. So 4, 5, or 6. 6 to 6, 7, 8. 8 to 9, 10. 10 to 12. Okay, that's how we could do it more accurately, but we do need to go up to 18. So what I am going to say is then just have one final one here, which is going to be 13 to 18, which should just be the last one there. And then if there's lots of people in that category there, we could break that up to be in more detail as well, actually. Okay, question 9. It says, Jade is planning a weekend break to celebrate her 21st birthday. The weekend break costs £350. Jade's father says, if you save 21% of your earnings each week for the next 20 weeks, I will give you the rest of the money you need. Jade earns £72. So we need to go and work out what is 21% of what she earns each week and then times that by 20. Okay? So the way that we're going to start doing that is say 10% of £72. Can't write. £72 would be equal to £7.20. So 10% again would also be equal to £7.20. So the two of those would make 20%. And then to make the 1%, divide 10% by 10 would be 72p. If we add those together, we're going to find out 21% is equal to 2, 11, 15, £15.12. So that is how much money she's going to save per week. She's then going to do that for 20 weeks. So we want to do £15.12 times by 20. So I'm going to do that as the 15 quid and the 12 pence separately. 15 times by 2 is 30. Add a 0 is 300. 20 lots of 12p would be 240 pence, which would be £2.40. So then put those together, we get £302.40. She needed to get £350 and was short, which we knew she would be because her dad said that he'd give her the rest. So how much, we're asked how much is Jade's dad offering to pay towards the winter or the weekend break. So it's going to be whatever takes us from there up to £350 there. So the way that I'm going to do that is say that if I'm on £302.40, I want to get to £350. That's my goal. If I add 60p, that'd take me to £303. If I add £7, that'd take me to £310. Add 40 quid, that'd take me to 350. 14, 7 and 60 makes £47.60p. From Jade's dad. Part B, we're told Jade has bought a new suitcase that can hold 65 litres. What is 65 litres in centimetres cubed? They're expecting you to know this definition. It's one of the ones that you need to learn for the exam. 1 litre is equal to 1,000 centimetres cubed. So 65 litres would be 65,000 litres, 65,000 centimetres cubed. The next one they want as well, it says Jade's new suitcase weighs 3 kilograms. When it is packed, her suitcase must not weigh more than 25 kilograms altogether. What percentage of the 25 kilograms does Jade have left for packing? Well, she has 25, but she needs to discount 3 because that's what her suitcase weighs. We divide that by the original amount, which is 25. That would give me 22 out of 25, but we want it as a percentage. It says what percentage. So we need this to be out of 100. Times 25 by 4, we get 100. 22 times by 4 is 88. So that would be 88%. We're then asked which one of the following formulae could be used to work out the volume of Jade's new suitcase. A, B, and C are measurements in 3 dimensions of the suitcase. Now this one here is A, so no squared, that would be an area. So B squared is an area because it's squared, and C is a length. If it's just a letter by itself with no power, it's just a length. If it's got a squared, it's an area, and if it's got a cubed, it will be volume. Now that has a length plus an area plus a length. You can't do inconsistent measures, so that's none of them. It's irrelevant. Ignore any numbers, including pi, which is a number. We've got an area, so we've got an area squared as an area times by a length, which would give me a volume. Take away an area, so that is also a nonsense. Here we've got a length times a length times a length, so a length cube, which would be a volume, plus, ignore the pi, an area times by a length, so that would be a volume plus a volume, it could be that, that's got potential. Volume, take away area plus a length, that's a nonsense, you can't have this, you can't be inaccurate here, and the same is true here, so that's the only one that works. We're then told here, it says Jade needs a new passport photograph. Passport photographs must be 45mm high by 35mm wide. Jade has mathematically similar photograph that she could reduce in size as her new passport photograph. The height of this photograph is 9 centimetres. Now just watch out here, that's in centimetres, they've asked for it in millimetres. So we need to change either that in centimetres, so 4.5 centimetres by 3.5 centimetres. Okay, so her photograph that she's going to reduce, we know is 9 centimetres. It needs to get smaller so that it's now 4.5 centimetres. So in other words, I need to halve it to go to the smaller one. This has got to be 3.5 centimetres, so to work backwards, this would be double that, so this would have to be 7 centimetres. Okay? Question 10 says, the picture shows a mountain hut. The hut stands on a rectangular base and has a uniform cross-section area, so it's consistent throughout. Draw a sketch of the plan view. Now, the plan view is literally just what it looks like from up above. If I'm looking down on it, what would I see? So basically, if you think of Google Maps, what would the satellite image see of that? Well, it would definitely see the two sides there, and then arguably it might see a faint line there, the peak. Okay, so either a rectangle that has no peak, that, or that. Now, part B says the mountain hut is shown on a map. The scale of the map is 1 to 50,000. Now, what that means is 1 centimetre on the map is worth 50,000 centimetres in real life. I'd never measure in centimetres in the real life, especially 50,000. Well, I wouldn't measure a distance from here to somewhere else in centimetres. Like, even if it was just down the road, it'd be meters or kilometres. Okay? So I'm going to say 1 centimetre is equal to 50,000 centimetres. I'm then going to get that into a more suitable thing to work with, so either into metres or kilometres, okay? So I know that 1 centimetre is that, so then dividing that by 100 would tell me that 1 centimetre is equal to 500 metres. Ah, there we go. It wants my answer to be in kilometres. So then to change 500 metres into kilometres, it would be half a kilometre by dividing by 1,000. So it says on the map, how far is 4.2? So 4.2 centimetres. Oh no, I haven't got a calculator for this. However, it's not as bad as you'd think. It says, what's 0.5 times 4.2, which sounds hard, but do it the other way around. What's 4.2 times by half? What's half of 4.2? 2.1 kilometres. Okay, so that answer there, 2.1. Okay, the next one's quite a tricky one. Take a moment to read it. I'll show you how to do it using your compass in a second. Okay, and it says, the map shows below the placement of the 4 wind turbines and a road connecting the 2 turbines. A new wind turbine is to be built. It is to be placed on the road connecting the Bryn turbine and the Cum turbine. So it's on this straight line here somewhere. And we're told it has to be on the perpendicular. Now that just means right angles from ABBA. Now, I've got to make 90 degrees at the point. Okay, so the way that I do that is I open my compass from ABBA to a place that it's going to meet on that line somewhere. Okay, now what I'm going to do is draw an arc that has to cross the line in 2 places. Okay, now from this arc here, I'll draw a blob here and here. I am not going to touch the width of that compass. It's exactly the same width as it was before. And you'll see that ABBA goes through there, which means that this is actually in the centre of this line here. That's the whole point of why I did it from there. Then, going over to this blob here, which I've already highlighted, I'm now going to put my point there, which again, that should go through ABBA. You can see it does. And then, getting a ruler, you line up ABBA and where the compass crosses down there. This road that I've just drawn in pencil here, this nice big bold road, that is on the perpendicular. You can see there that I've made 90 degrees there. Okay, so it says that it has to be on the road connecting the Bryn and the Cum turbine. So it's got to be on here and it's got to be at 90 degrees. So it's this point here. That's where they want to build this one called Ifeil. Okay, so that's Ifeil there. We're then told the map is drawn using a scale of 2 centimetres represents 1 kilometre. Okay, so we've done that's what we're going to have to use now. It then says how far is the Eiffel turbine from the Dewar turbine. So here is the Dewar turbine. So now I need to measure in centimetres how long that is. Now I make that 7.2 centimetres. And we know, so if I write down here 2 centimetres is equal to 1 kilometre, I've just measured that as 7.2 centimetres. So basically, to change it from centimetres to kilometres, I divide my answer by 2. So half of that would be 3.6 kilometres. So that's what the distance is. Okay, 3.6 kilometres. Over the page, it says Gwen records the time that she spends writing each of her 240 text messages. The greatest time is 1 minute 5 seconds. The range of time is 60 seconds. Now, as you go through these bullet points, you can see things here. Now, everything's in seconds so far, bar the top one. So we need to have them all in the same unit of measure. So 1 minute being 60 seconds and 5 seconds would be 65 seconds. The range of the times is 60 seconds. So if I do 60, 65, take away something to get 60 seconds. 65 take away what is 60? So 5 seconds is the lowest. And then The median is 45 seconds. The lower quartile is 23 seconds. The interquartile range is 32 seconds. Use graph paper to draw a box and whisker diagram. So we're going to draw some. Okay, this is the lowest, this is the highest. Now they've told us the greatest time is 65 seconds. So I don't need to go higher than 65 here. It doesn't need to go higher than 65. It could go up to 70, I suppose. And then the lowest is 5 seconds. So it's probably going to go up in tens. So 10, 20, 30, 40. Now, we only need to do it for this one here. So 10, 20, 30, let's put in 0 there as well. 40, 50, 60, 70, and that's the time in seconds, isn't it? Okay, so I'll just put that in brackets. The lowest time I've already worked out was 5 seconds. So I'm going to draw it just purely using all of the middle one here. But you could do it bigger if you wanted. The highest was 65 seconds, so that would go there. Okay, I'm now going to connect the lowest and the highest together, doing a line just straight through there. Okay, now the next thing we're told, so if I start working through my bullet points, is the median time was 45 seconds. So at 45 seconds, I draw a line. The lower quartile is 23 seconds. So 1, 2, 3 little squares on from there. That's the lower quartile. Dealt with that now. Until the interquartile range, so the upper quartile, take away the lower quartile. So take away 23 is equal to 32. So how can I work out the upper quartile? Well, if we add 23 onto both sides, we'll get the upper quartile is 55 seconds. So again, just draw that line there and then connect the bottom to the top of the lower quartile and the upper quartile. Okay, so it should look something like that. Okay, some people don't draw that line going through the middle, but I'm absolutely happy to leave that in there. Okay, we're then asked for part B. It says how many people or how many of these messages took when more than 23 seconds. Now this is 23 seconds here, and we're after more than that. So we're after the majority of this diagram. Now the way that this is split up is that each sector, lower quartile, is in quarters. Lower quartile to median is half, will be 25%, 25%, and then 25%. Okay, now in order to work out this much here, it's 75% of 240. So 1/4 of 240 would be 60, so 3/4, 75% would be 180. Page, and on to our last question. We're told there is a queue of 96 people waiting to buy a concert ticket. Liam has 8 vouchers to hand out, offering 20% off ticket prices. He has decided to use systematic sampling. Okay, so not anything other than systematic sampling to select who receives these 8 vouchers. Liam has randomly selected the 6th person in the queue to receive the first voucher. Use the table below to give the positions in the queue of the 8 people who receive the vouchers. So we've got 96 people and 8 vouchers. So what we want to do is do 96, the number of people, divided by the number of vouchers, which would be 12, and we want to count every 12th person. Now ordinarily you just start off with the first person, then add 12, so the 13th, then add 12, 25th, but he's decided to choose the 6th person in the queue. So we just keep on adding 12 to that. So 6 add 12 would be the 18th person, add 12 would be the 30th, 42nd, 54th, 68th, 78th, and the 90th. They would be the people in the queue. We're then asked, or we're then told, Gerald has used his 20% off voucher to buy the tickets. He paid 128 tickets using the voucher. Okay, 120 quid, 20% off using that voucher. That's what he's used. Okay, now from there, we're going to say that the original price, so 100%, with a voucher to reduce the price to take off 20%, is equal to 120. 100% take away 20% is 80%, is 120. Now, I don't want to know what 80% is. I want to know the original amount, okay, what it was originally. So to do that, I'm going to divide both by 8. 80% divided by 8 would be 10%. 120 divided by 8. I'll just do bus stop for that over here for safety. 8 into 12 goes once, remainder 4, 5, 15. So that 10% is equal to 15. So now I can find 100% to be 150 quid. Okay, that's the end of that paper for the intermediate. If that is useful, please hit the subscribe button and you'll get access to any more papers as and when I release them. Thanks very much for watching.